Let f be a continuous function on the closed interval from -2 to 1, where f of -2 is equal to 3 and f of 1 is equal to 6. Which of the following is guaranteed by the intermediate value theorem? So before I even look at this, what do we know about the intermediate value theorem? Well, it applies here. It's a continuous function on this closed interval. We know what the value of the function is at -2. It's 3. And f of 1, they tell us right over here, is equal to 6. And all the intermediate value theorem tells us, and if this is completely unfamiliar to you, I encourage you to watch the video on the intermediate value theorem, is that if we have a continuous function on some closed interval, then the function must take on every value between the values at the endpoints of the interval. Or another way to say it is, for any L between 3 and 6, there is at least one c in the interval from -2 to 1, the closed interval, such that f of c is equal to L. This comes straight out of the intermediate value theorem. And just saying it in everyday language is, look, this is a continuous function. Actually, I'll draw it visually in a few seconds. If this is continuous, if I were to draw the graph, I can't pick up my pencil, well, then it makes sense that I would have to take on every value between 3 and 6. Or there's at least one point in this interval where I take on any given value between 3 and 6. So let's see which of these answers are consistent with that. And we only pick one. F of c equals 4. So that would be a case where L is equal to 4. So there's at least one c in this interval such that f of c is equal to 4. We could say that, but that's not exactly what they're saying here. F of c could be 4 for at least one c, not in this interval. Remember, the c is our x. So the c is going to be in this interval. I'll take a look at it visually in a second. We're not saying for at least one c between 3 and 6. We're saying for at least one c in this interval, f of c is going to be equal to 4. It's important that 4 is between 3 and 6 because that's the value of our function. So I'm going to rule this out. They're trying to confuse us. All right, f of c equals 0 for at least one c between -2 and 1. Well, here they got the interval along the x-axis right, but it's not guaranteed by the intermediate value theorem that f of c is going to be equal to 0 because 0 is not between 3 and 6. So I'm going to rule that one out. I'm going to rule this one out, saying f of c equals 0. And let's see, we're only left with this one, so I hope it works. So f of c is equal to 4. Well, that seems reasonable because 4 is between 3 and 6 for at least one c between -2 and 1. Well, yeah, because that's in this interval right over here. So I am feeling good about that. And we could think about this visually as well. The intermediate value theorem, when you think about it visually, makes a lot of sense. And so we're continuous on the closed interval from -2 to 1, and f of -2 is equal to 3, and f of 1 is equal to 6. And so let's try to draw a continuous function. So a continuous function, it includes these points, and it's continuous, so an intuitive way to think about it is I can't pick up my pencil if I'm drawing the graph of the function which contains these 2 points. So it takes on every value. As we can see, it definitely does that. It takes on every value between 3 and 6. And so if we think about 4, 4 is right over here. But you can see it took on that value for a c, in this case, between -2 and 1. I could have drawn this thing as just a straight line. I could have drawn it like this. And then it looks like it's taking on 4 only once, and it's doing it right around there. This isn't necessarily true, that you become 4 for at least one c between 3 and 6. 3 and 6 aren't even on our graph here. So there's no guarantee that our function takes on 4 for one c between 3 and 6. We don't even know what the function does when x is between 3 and 6.